Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. It was recently pointed out to me that I mumble my way through that every time. Not every time, but most times. And YouTube thinks I say things like, "Hey guys, it's Cohen." And I'm really mad about it. Anyway, this is Ferris Makes Demos episode 49. Last week we went over some stuff with our 64K synth. It's been open sourced. I believe that was early last week. And since then I got really excited about multi-threading the rendering. And so last week on the stream we did that. And I knew I kind of just like threw together an implementation that wasn't that smart. But I figured that I would get it to work and then kind of think about how we would improve that. And luckily, I was able to fix all the bugs that I found and get it fairly robust. And a quick note on that, for those of you guys that caught this last week, I was totally right that terminate thread, it seems to be that when you call terminate thread on a thread that hasn't entered its callback yet, like its thread procedure, then subsequent threads that you try to start up seem to not start at all. So that was definitely something that we did wrong. And then the other thing that we saw at the very end of the stream seemed to just be contention between the main thread and the worker threads. So stuff was never actually getting rendered. So with a couple smart sleeps and stuff inserted here and there, it actually works really well. I made a PR for that. And luckily, some guys who are better at Windows threading than I went and saw this, particularly G. Suberland, who is often in the chat, and also Kebby, of Farbroush fame for you demo scene guys. They provided some really nice feedback, and in particular, I think I'm going to implement what Kebby has said today, because it seems to be the simplest way to do this. And I'm just going to take the code as it is, as I've submitted in that pull request, which is a little bit different than what we had last week, just a bit cleaned up. And we're going to make that work, and then I'm going to push that again, and that should be the stream. By the way, hi to guys in the chat. Daniel Cullen, I really like your emotes, by the way. Mortare, thank you so much for the bits, even if they're dusty. Flag-CA. Zokwar, Bomba, Wistertobe. Hoffman, how's it going? Yeah, Bomba also, I should point out, provided some good feedback on Twitter, just that sleeps are bad, which I agree. So yeah, really appreciate the feedback. By the way, our Slack group is open now. I just had to make sure we had invites and stuff for that. So if you go to our GitHub, you'll find the link there if you want to join in on any of these chats. So you don't really have to miss anything. Hey Kusma. Yeah, Kusma just got VS 2017 builds working in probably the cleanest way that I've seen so far, so I'm really thrilled about that. And hopefully we can move over to like CMake or something, and then we don't have to have multiple Visual Studio Project versions lying around in the repo, because that kind of sucks. So it's really cool. I really appreciate the community efforts so far, because we've been open source for like a little over a week, and already a lot of good changes have come in. Oh, I need to whitelist Hoffman. I still have links disabled, so people don't post stuff in my emulator streams. I'm gonna do that really quick because Hoffman should really be in there. Think this. Oh. Yeah, IRC should work. That joke does suck, Kuzma. Go home. Regulars. DJ Hoffman with an O. Yeah, that should be fixed. Anyway. Anyway, so I want to go over this PR that I made, and then we'll talk about what we're going to be implementing today. I know the font size isn't going to be ideal here. I can zoom in a bit. Anyway, so I made this pull request, and it contains all the stuff we did last week, but bug fixed. I'm really happy with these results. This is basically anywhere from 40 to 60% faster, depending on the number of cores in the song. Of course, the single core case gets a bit slower at the moment. That should actually be fixed when we implement Kebi's thing, which is cool. And then what I also did, I think I showed this on the stream last week, is I hacked in this trace capture stuff. So this just shows this same render samples call when it's rendering an entire song, but it shows how the work is distributed between threads in the new code versus in the old code. They're not exactly to scale; they're kind of close, but I couldn't get the zoom on the trace viewer to be exactly the same between these shots. But this is still relatively accurate in terms of scale, and you can very clearly see how much faster it is with the multi-thread stuff. Daru2, when you open a PR on Logic Coma Corp, do you then review it yourself and act really harsh with yourself? Yes. Absolutely, I do. And I especially point out all the minuscule whitespace errors, because that's what good developers do, apparently. That's a little jab at the other Hoff over here. Anyway, so this just showed some results for that I'm really happy with. And I also packed up a version of Trash Panda that renders 3 on 3 cores, which is here. And then it was 188 bytes larger, which is not bad. I think with the stuff we implement today, this will grow a tiny bit, not much. I'll do another comparison after this. I won't do these shots again. I still have on a branch the trace stuff, but I just don't want to hook it all up again and then clean up the code again, because I put it into little commits. So I like to do this, where it's like, here's one where we remove a critical section from existing code. Here's one where we fix one of the callbacks in existing code. And then those are 2 like bite-sized chunks. Like I could have put those in another PR if I wanted to. And then make track receipts public, and then do the multi-core rendering, and then introduce this critical section abstraction that just helps us out a little bit. And so I think we actually won't use critical section anymore with this. So we're going to be okay. But in fact, no, I think I will still use this in some of the top level code where the demo communicates with the real-time player. But anyway, some more stuff on the single thread case. G. Suberlin talked about how we can use like create event to stall the threads the proper way. So I'm using, I essentially have the dispatch thread and then the worker threads. And the dispatch thread will dispatch some work and then wait for the worker threads to complete. And the way it does that is it sort of spins in these wait loops where it checks some condition, and then if that's not met, then it will sleep for a while. And that's okay. I mean, the scheduler in the OS will eventually go through all the threads we need, but we're wasting a lot of cycles on those spin waits, when what we should do is just signal the thread as waiting on something else, and then let the OS wake it up when something else signals that condition explicitly. And in Windows, we can do that with events, I think they're called. And then use like this wait for single object or wait for multiple objects to wait for a certain event, and then set events from another thread will actually cause that to wake up. And with that, we can have the threads essentially sleeping not just for until the next like available time slice, but they're going to be sleeping until some conditions met. So they will never have contention on any of our resources when they're not actually being active. So this is a bit better. I'm not sure if I'm explaining that in the best way possible, but that's essentially all we need to really know. And then we go back and forth a bit on talking about possible deadlock conditions and some other things. You can read this on the PR if you guys want. And eventually I came up with, I think, a strategy for this, which I think just matches what G. Suberlin said in different words. And then Kebi came along a couple hours ago, and he pointed out that he had kind of a better way to do this. And I really like this because yeah, it just seems a little better. So essentially what he does is he has a start event per thread. And then what happens is that those threads will start and just be waiting for these start events with this wait for single objects on each thread. And then what he ends up doing is, so he waits for the start event for the particular thread. And then once that's signaled, this is on the worker threads, then if there's this exit flag that we set globally, then these threads are going to return, and then they're going to be done with their work. Otherwise, they're going to find some work. And then if they found some work, they're going to do the work. Otherwise, they're going to break this find work loop. And then they're going to interlock decrement how many threads are running. And this way, if this goes down to 0 with this interlock decrement, then essentially the one that saw that this would go to 0 would then set event for the work being done. What I like about this interlock decrement here is that there's no contention on this, except like an internal spin weight in the CPU, but that's not really anything we have to worry about. And this is just signaling that all the work is going to be done and make sure that we only set this event once, which is really nice. So we have essentially a start event per thread and then a done event at the very end. And then we know once we hit this done event that actually all of the threads have been done, or at least have known that there's no more work left, which is really good. So then on our main thread, we can schedule the work being done, then set the threads running to the number of threads, and then we actually set the start event for each thread. So we know no threads are running at this point, so we can just set up whatever we need to set up. Then here, and we set up the condition that the threads are gonna set at the end. Then here we actually fire off all the threads, and then we wait for the single object. I'll get to this in a second, but then we wait for the done event, and then we're done. But here's the other clever thing that this does that I really like. Instead of like we have sort of one potential problem, and that's the single thread case gets a lot worse. Or not a lot worse, but enough worse that it's noticeable. So if I go back to these performance charts here, this left column is the render time for an entire song. I think I did Trash Panda, or no, I actually did several songs here. So this left column is how long each song took to render, just the entire song, no additional I/O. It's just rendering to buffers and throwing away the results. And this is a single core case. This is what we had before this PR. And this is what we have in this PR with 1, 2, and 3, and 4 cores. And because of the extra little administration here, this ends up being a bit slower because it would still have to wait for a separate thread to take up the work and then finish it and send it back to the main thread. So there's a bit of overhead here, and it is noticeable, a few percent worse, which is not ideal. I did have a patch to do this, but it took some special casing stuff. But Kebi's suggestion actually gets around this in a way that I really like. So what he does is the render threads actually don't just run this function, they run this loop here. And this run render thread function where you pass in the thread number is kind of where it gets cool, because this is how you identify like which event you're going to send on and stuff. And the idea is that you actually would have spawn one less additional worker threads than the amount of worker threads you do, and you let the main thread actually do the work that the first worker thread would have done. This way, if you don't actually have any additional worker threads, this all just happens sequentially, and then like this set event and wait for single object and stuff was essentially no ops, because you're setting the event here that you're waiting for here, and because this ends up already signaled, then you're fine. And then in the multi-thread case is the same code. So I really like this, and I think, again, he says here, no sleeps, no state variables, guaranteed deadlock free, no special treatment for single core CPUs. You don't even need the critical section in the main thread anymore because all render threads are guaranteed not to run at the moment, which is really nice. And in fact, there's a critical section here where it finds the work. And oh yeah, Drew2 says, can I share the link? I think I did earlier, but I'll share it again. It's not a problem. Here we enter a critical section to find the work and then leave the critical section on there. But I think what I actually want to do here is go through and try to find work. And then when we find a piece of work that we can do, we try to compare and swap the state of that work. So essentially an interlocked exchange on whatever work item we're going to take. And then we have even less contention here, even though the threads might spin looking for work, but I don't think that's a problem. So I think this is pretty good. I think this is about as good as we can expect. And we can do with this find work thing too. I think we can like try to short circuit this in a way. Like we can always check that if the last state is done or not, for example, as sort of an initial condition, and then start looping through the thing. But I'll probably just go through the entire list anyway, because it's not a big list. It won't take very long. And we're just doing reads on all those values too. And even if we do a read that happens like at the same time, that misses the the right previously, then we'll just hit the list again and we'll be fine. So I think we don't need any critical sections in this code then. And just a couple signals or a couple events. And then this starts to look really good. So I'm really happy about this, actually. I think this is a really good solution. And I think this is the one that I'm going to implement. I'm just going to refresh really quick to see if there's any more comments. I don't think there are, though. But yeah, so I said thanks and going for this. So yeah, thanks again to Kebby for pointing this out. This is definitely what I'm going to do. So move some windows around and then we'll do it. If you guys need me to bump up the font size, I can do that a little bit. Actually, I'll just 4 clicks. I hope that's enough. It's very disturbing for me, so hope we don't need this higher. Anyway, so we should be able to remove a lot of stuff here, particularly I still want to do this render thread shutdown thing, and this num float samples thing we also need so that they know how many samples they're going to render. Num render threads here is okay. We have a handle to the render threads. We're also going to need handles for the start events and the done event. And we're going to get rid of the critical section. So we'll just do that first. So this will be num render threads and the render threads. And I think I'm actually going to rename this to additional render threads, just to make it a bit clear that we're going to use the main thread as sort of a first worker thread. I call it the main thread because it's like the thread that's dispatching the work. It's actually not the main thread. It's actually what previously was the render thread. But yeah, I guess I could also call that like additional worker threads, but I think that's okay. And then render thread shutdown, render thread num float samples. We'll do int additional. Actually, we'll do render threads running. And then we'll do handle additional render threads, additional render thread start events. I know these are really long names, but I think that's fine. And then handle done events. Good. So we're going to do one more thing here, and I'm also going to move this, by the way, which will just vanish into the commit once I clean up the history for this. But I think I actually want to have an instance method here for doing the rendering, because the first thing this render thread proc does is it gets through this LP parameter here, it gets a handle to this object anyway. And I don't really care if we're kind of mixing threading and threaded and not threaded code that much, as long as it's relatively clear what's going on. This too is in the player part of the WaveSabre repo, which is kind of one of those parts that users of the synth, whether they're musicians, if they're musicians, they basically never touch this. If they're coders, they probably never touch this. Like, this is very unlikely to be messed with by people. So I think we're kind of in the clear in terms of people breaking this. Anyway, I think this will just be something like void render thread work. I'll probably come up with a better name for that. And then in our setup here, this is going to be additional render threads. And this actually will do this -1 now. And I'm going to do a couple other things here. If we will special case some stuff here. If num render threads is greater than 1, then we'll do this. Otherwise, we'll just leave it uninitialized. That's fine. So let's shut down. We don't need to set the float samples or the threads running right now. Then we'll create those other events. So I think we use create events. And the security attributes I think can be null. I need to look up this function here. The other thing, which I'll talk about here in a second. Yeah, null, that's fine here. Manual reset. So we do not want to do manual reset, I think. I don't think we need this to be manual reset, because I think since we only ever have like one, would you call it a transmitter or a broadcaster? Like a broadcaster and a receiver, sender and receiver, I guess. The sender is going to set the event, and then the receiver is going to listen to the event. All these events are only going to have one sender and one listener. So I think it's okay that we just let these reset by themselves, which should save some code. Oh yeah, it does, doesn't it, Hoffman? That's funny. Domina sub. That's how I interpreted your comment, Madmouth. Yeah, I really need to change my bio since I still work at Fuse. By the way, I think it's actually okay that I mentioned this. I'm actually changing jobs again. And I think that's a great shocked face, Mad Moose. I'll update you guys on the details of that in a few weeks. But it's just kind of funny that outdated bio is now going to be 2 jobs behind pretty shortly here. So this initial state, we want to do... initial state, I think we'll just do false. Because we want everything to wait until it's explicitly signaled. So that's what we want to do here. And then the name, do we need a name? Yeah, we don't need the name. That'll save us some bytes. Although I guess then this name is probably useful for like debuggers and stuff, but that doesn't really matter. Yeah, we're gonna screw that. And then for threads -1, we don't do any checks on this parameter, but we're gonna assume that it's not stupid. For example, 0 would be terrible. To be at least 1. I could probably document that in the API, but honestly, just use the examples. And if you pass 0, this will do fun stuff anyway. Actually, it won't. I think this will be fine. But yeah, this will be... Oh yeah, I was creating these events. And this needs to be also done event is one of these. But we also need to do that for these other start events. Because we just want to set these to like some initial states that mean that the render threads aren't going to be doing any additional work. I think because they'll all wait till that event is signaled, I think that'll be fine. But let's just see, because the order in which we actually set the stuff up is going to be determined by what the threads actually do. In any case, I'm going to do this stuff. So render threads here. And then we're going to create the... Actually, I think we're going to create these done events anyway, or the start events. Let's just always do this, actually. The other thing with these threads is we need to we might not just send this here. We might send some kind of pointer to an object that also contains the thread number. We'll get to that. Anyway, we've set up our done event. We set up the threads. The start events we actually should also have ready before this. I think this is what I want to do. And then I think all these just need to do is also same thing here. I like this. Thanks, Guzma. Appreciate it. Yeah, so here's another thing I'm going to do. We're going to set the shutdown thing here, and then we're going to wait for the threads to shut down when we're deleting stuff. So let's just take care of that now while I have the init code here too. So this is going to be if num render threads is greater than 1. Then we're going to do wait for the render threads. So this is going to be this -1. So this will be additional render threads. Wait for all those to be finished. Delete them. And then we also want to delete this other stuff. We're doing this first so that none of this other stuff gets clobbered by one of these threads if they're running, which it shouldn't, but just in case. So here we're going to do, I'm guessing it's delete event. Doesn't look like it is. Oh, close handle. Should probably be using that for the threads too. I'm gonna do that if I should be doing that. Yeah, close handle I should be doing. Do that here. So this will do this. And I'll do this too. Okay, and then here we're going to do for this then render threads. Okay, I also want to rename this to render done event. I like this. So then we dispatch the work. We don't need the critical section anymore, which is nice. So we're literally just going to set all these states to idle. So that's the scheduling here already. And then set up work, dispatch work. Wait for them to complete. This part gets really nice because we're just going to do wait for single object. And then this ends up being render done event and infinite. And then here, this becomes really easy. Actually, we do all this for this one. Then we do set event. This will be render threads start events I. So this tells everything that the work is ready. And then we're just gonna wait for that. And the last thing we're gonna do is dispatch work for this main thread here. So I think I called that render thread work, and we also want an int render thread ID, or rather render thread index, I should say. And so here we're going to do 0, and we're good. Now we need to make sure, again, that these other threads know what their index is. And the reason we need that is because we need for each of them to know which start event to wait on. So I'll get to that in a second. First, I'm going to do this. And then this should all just go here, more or less. And here I think we have a bunch of song renderer stuff that we're going to get rid of, because now we have this pointer is valid. Also, we no longer have this critical section, so we'll get rid of that. A lot of these, and I'm just kind of letting the compiler tell me what to do instead of reading, which is always fun. So the first thing this is actually going to do is wait for single object, and we need to do that's thread index and infinite. Again, we'll use the same sort of antisignal that we're done at the very end, which is here. That's something we definitely need to do. Don't need this comment anymore, perhaps. I think this is what we want to. No, yeah, because we don't need to wait for that at all. And yeah, technically we would probably only need to do this if we have additional render threads. I'm actually going to put that in there. A little bit asymmetric with some of our other code, but I think this is okay. We sell the events, then we wait for everything to finish, and then we close up those threads. Delete all that stuff. I like that. Yeah. Good. I think all this is actually going to do. We do need to check the shutdown condition here. And I'm not sure how I want to do that. Nice memos. That work. Thank you. I think I need a second. Yeah, I think the easiest way to do this is just have this return a bool. Because then we just have while render thread work. And this will be, what would I call this? Like that. And then this will not allow me to run this until we actually solve that, which is good. So yeah, we'll wait for the object. And then let's do this. If render thread shut down, return false. Yeah, this is what we want. And then this loop is essentially while we have work to do. So we're going to do this, actually. We're not going to sleep. And we're going to move some stuff around here because we no longer have to do stuff. It's okay that we just do the assignment here, not interlocked, because the only way that we're going to set finished on this is if we already did an interlocked exchange to set this to rendering. I think we're good there. Getting a little tired here, but we're close. And in fact, we don't even need to do this as separate stuff. Like this. So the easiest way to do this is actually this. Yeah, so here's our early out condition. And we don't need this here anymore. We can move this here, for example. Probably going to rename it. I think we can just call this I at this point. And look at me not using Visual Studio efficiently. And we can't hear, actually, but this is fine. I don't care. Let's use J. Good. And this is fine. Don't need to comment that. And then this needs to be interlocked. We're almost there. Yeah, so that's what I'm getting to, Mad Moose. So we don't need to synchronize track render states in the dispatch because we know none of the other threads are going to be touching this at this point, because they're all going to be waiting on their start events. When they are running, this one needs to be synchronized. So, really? Apparently the interlocked compare exchange docs are missing right now. So here's what I'm thinking. We'll do this. Exchange values, we want to do. So essentially what I'm trying to do here is we're going to find a track where we know we can do work. And once we do that, we're going to try and mark that as we're the ones taking that work. And this may fail. So we need to do some things here. I think I also need to cast these to ints, or unsigned ints, that is. And then I think this is okay. This pointer cache should be fine too. And then this is going to return, I believe, the value that was in there. And we need to make sure that that was rendering. Let me double check on this. Yeah, so it should compare the one in this pointer and this value. If they're equal, it will swap the value that was in there with this value, and we'll know whether or not it did that by the return value, which is going to be the initial value of this, which we hope is idle. So that. like that. I think we need to do this the other way, though. So that we do all of this here. I think that would do it. And then we don't even have contention on this work list. The last thing we need to do here, though, we're done here, so we're going to do this. This is going to be... if this ends up being 0, then we're going to set event. That's how we'll signal to the main thread that everything's done. Oh, what? Also, I just thought of something for this. Let's actually use longs here. Just to make this symmetric too. We may want to not do casts here and do the proper types for that. In fact, actually, let's go back to unsigned int. I think this will just work now. And then we'll do this here. I think what we can do is we can do on these enum classes here, I think we can explicitly set their backing type, and then I don't even know if we need to have these casts. I don't remember how to do that. I think you can do, yeah, colon then the type. So we can do like render state, check render state here, unsigned int. And then I wonder if we even need these casts. I think we still do. But at least we know that these casts are safe then. So I'm happy enough with that. But yeah, I think this will work. It's fine that we're only reading stuff here. And when we actually do the write, we do that interlocked. So we're not going to be doing any duplicate work. And again, if this fails, we're just going to hit the next one and search for work after this, which is ideally what we want to do. And at the end of all this, yeah, we're going to make sure this is okay. The last thing I want to do, by the way, I don't think we set this either, which is render threads running. I don't think we set that. So this will work properly. And then we're looking good. And the last thing we need to do is get this thread index here somehow, which normally we do that with this LP parameter here. We're using that for the song renderer pointer right now. But we could like allocate structures for this. Are new and delete thread safe? I assume they're supposed to be. Yeah, Rusty would not be happy about this at all. I'm going to assume we're probably okay here. And then we don't need much here. Or I just have to remember this. That's how you do that, isn't it? Yeah, we just need some stuff in here. So we'll do song render. And we need also did I do that right? Render thread index and the song renderer. Do that. So now we can do this. Where do we create the threads? Here. Can I do this in C++? I don't remember. I'm just gonna do this though, honestly. So data dot no. What is this? That's fine. So then this will be the render thread data. And then here, we can do this. I think this will work. I don't know if I like the way I did that, but we'll see. Appears to work. Appears to work just fine. And I'd be willing to bet This might look a little prettier in my task manager now. Not really any noticeable difference here. Using a couple percent CPU, if that. Rendering a really shit simple song. I'm actually going to run this converter here. I don't know what song this has in it right now. Let me unmute the system audio for you guys. Okay, I guess it's a test version of Trash Panda. That might have been really loud. Kind of hope it was for fun. Let's do a different song, actually. I think I was running that small clip of that song so I could get those trace images that I had in the pull request. This is all of Trash Panda. And my task manager is running at a couple percent CPU still. Oh no, we're running around 11-12%. That's actually great. This is still multi-threaded. And this is normally a pretty heavy song. But I like this because this appears to work, and there's no reason why it shouldn't. And it should make a clean exit as well. I really like this approach. Quite a lot. And I just want to make sure that we're still okay in this case, where the threads is 1. Should be. Yeah, that still works. Nice. This appears to work great. So the next step with this is going to be like really stress testing this again, writing out entire songs. The CPU use seems to be around 11% on this, but it's going to vary throughout the song, and we'd have to wait till that part of the song to really see it. But I like this. I think I might have to go through again and just do more timing tests like I did on the pull request before I'm particularly happy with this. Yeah, I should run backscatter. That song's still super heavy. Let me go and find where that stuff is. It's in the folders where the things are. In this one important folder. Called this one important thing. Appears to work fine. Actually around 6% CPU for this part. I expect that to go way up. I'll crank this a little too pretty. Not that bad. I'm gonna peak this a little here. 5-7%. Not bad at all. Of course, mem usage is consistent. I don't think we do any dynamic Alex when the synth is running unless you resize buffers. Like adjust delay length or something. And you can see that the CPU usage kicks up about a second before we hear the song get more complex. That's normal because the way the real-time player is set up, it has a second of latency, which gives the renderer a lot of headroom. And it's totally fine for like a demo where this is non-interactive, so you just want very consistent delay so that we can sync everything. I like this song. This is actually coming up on the heaviest part of the song, like the ending arps with all the pads and everything before the second drop, I think is the heaviest part because of polyphony. Polyphony, polyphony, I don't know how you're supposed to say that. Only getting it to like 8%. That's nice. Not bad at all. Chrome and OBS are both just eating its lunch. And in fact, when I do proper speed tests on this, I'm gonna do it without running OBS. Thanks, Pyro. I love that this worked first try, by the way. That's awesome, Mr. Tube. I'm really proud of that track. I didn't think that many people liked it, but I really think it's cool. So I'm glad you enjoy it as well. I'm probably gonna stop the stream pretty quick here. I'm gonna do these speed tests next, but I'm gonna do them without OBS and everything running, and then I'll clean up all these changes and get them into the pull request. But I want to say again, thanks to G Superland and Kebby for their feedback, and Bomba as well. Really appreciate this because threading, and especially threading in Windows, is not my most comfortable area to work in. So I really appreciate the feedback, and also a lot of the other things that people are doing in our little community. Like Kusma's been doing a lot of pull requests as well, and just anyone who's trying the synth and using this stuff, I really appreciate that. But anyway, I think I'm going to go now. I think this was definitely a success, and I'll just prepare this and we'll get it released. But yeah, thanks guys, and I'll see you next time.